Good morning once again. My name is Olujimi Gabriel. Today we're talking about Pythagoras rule. Before we go into that, here are the correction for previous assignment where we're asked to find the 70% of sum of money, where 17 and a half of sum of money is 56 naira. We have to calculate the actual amount and we use our direct rule to actually calculate which the amount was 320 naira. Here is the second one. We have to find the equivalent of money in two different currencies, which are the naira and the sefa. Now here is the answer here. Now we move to today's topic, but before we continue, here are the objectives of these topics. Now, right angle. Now, this is a typical example of a right angle. The longest side is called the hypotenuse, while the two other side is called adjacent side. But this side is called adjacent, while this one is called opposite. You can see this angle is facing this side. It is called opposite, while the longest side is called the hypotenuse. Now, when you look at this diagram very well, you will see that we have a square here, a square here, and a square here arranged in such a way that we have the same number of boxes in the row and the column. Now, when you see that this one is 1, 2, 3, 1, 2, 3, the square here is 9. Now, the square here is 4 by 4. This also is 3 by 3. By the time you count the one you have here, the square of this plus the square of this will give the square of this. Example is shown here. The area of this side is 25, while the area on this side is 9, and the area on this side is 16. 16 plus 9 will give us 25. Now, it can be seen that the square on the hypotenuse is equal in area to the sum of the squares on the two other sides. That is, the square on this side, which is the longest side, equals to the square of these two other sides. I mean their sum, a square plus b square. This rule is what we call Pythagoras rule. That is, we can use this method to calculate the side of any right angle triangle. Note, a Pythagoras rule is always applied to a right angle triangle and not any other triangle. Look at the example here. This length is 3 meters, while this other length is 4 meters. We have to calculate the length of the longer side. Now, from our Pythagoras rule, we know that the square of this side, which is 6 square, plus the square of this side, which is 3 square, plus the square of this side, which is 4 square. By the time you add together, it will be 25. Note that 6 square equals 25. Now, c equals to the square root of 25, which is equals to 5 meters. That is how to calculate the third side of any triangle. Here is another example. The longest side is given, and this side is given to be A, and this side is 5 centimeters. We can also use this Pythagoras rule to calculate the missing length. Now, we know that the square of the longest side, which is 13 square, equals to the square of this side, which is a square, plus the square of this side, which is 5 square. Now, 169, when you square 13, it will be 169 equals to a plus 25. Now, this is simple equation that we have been solving over the time. Now, subtract 25 from both sides, we have this. Now, by the time you find the square root of 144, it will be equals to 12 centimeters. That is how to use Pythagoras rule to calculate the missing side of any right angle triangle. Here are some for you to do. The same thing still applies. You can see the longest side is 5, while this side is F is missing, and this side is G. Now, Don't forget the longest side first, which is a square equals to the square of the two other sides, their sum. X square plus g square. And what is x square? We don't have it. Look at it here. And g square. What's our x square? A square is 5 square equals to x square plus 4 square. This is 25 equals to f square plus 16. Now subtract 16 from both sides. F square equals to 25 minus 16. That is 9. The square root equals to 3. That is that. The same thing still applies here. Still the same process. Just identify the longest side, which is x square equals to other side, which is f square plus g square. It's the same thing still applies. Now this one also, you can see that we are using the same question to solve for each side of the right angle triangle. Now this time we are looking for the longest side, which is the x square plus 4 square plus 3 square, which is equals to 16 plus 9, which is 25. And the square root of 25 equals to 5. That means this side equals to 5 units. Now look at this one. We have two triangles joined together. Now you can see that we have triangle PQR and triangle PSR. You can as well have them in two places. This is right angle. Don't mind my diagram. This is 3, this is y, and this is 2. That means before you can find your x, this place is 6. Before you can find x, you have to find this side first, which is connecting the two triangles together. That means you first of all find the value of y from here. You know this one is complete. This one you have two missing sides, so you can't use this one. That means you have to use the first triangle to calculate the value of y. After which you now use y, 6, and x to calculate for x where we are looking for. Now this one is y square, which is here. Y square equals to 3 square plus 2 square. That is y square equals to 13. There may be no need to find the square root of 13 because we are still going to use it in the second triangle. Now in this triangle, x square is the longest side. That is x square plus y square plus 6 square. And our y square equals to 13. Just put it direct inside this second expression. Now 13 plus 36 will be 49. Now the square root of 49 equals to 7. That means our PS equals to 7. And our PR equals to the square root of 13. Now Pythagoras triple. A Pythagoras triple is a set of 3 whole numbers which give the length of the side of a right-angled triangle. Look at this. You can draw. That means this place is the longest side, which is 25. This side can be this, and here you have used those set of numbers to form a right-angled triangle. Now these are common example of Pythagoras triple. How do you know they are Pythagoras triple? When you square 7 plus 24 square, their sum must give you the square of 25. The square of 25. If that one is established, that means they are Pythagoras triple. Now look at example. Which of the following is a Pythagoras triple? Pythagorean triple, sorry. Now the first thing to do is you square 33 and 56. You sum them together. Now when you sum them, you have 4225. Now you now find the square of 65. If 465 square gives you 4225, that means this is a Pythagoras triple. Thus 33 square plus 52 square equals to 65 square. That means it is a Pythagorean triple. Now look at this side. You square 15, add it to the square of 30. Their total is 1125. Now square 35. The square of 35 is 1225. You can see they are not equal. That means this set of numbers are not Pythagorean triple. This sign means not equal. You can see it here. It means not equal. It is not a Pythagorean triple. Now, we can also write 4 multiples of, let's use this example. Now, you can multiply each numbers by 2 to give you 6, 8, 10. By the time you square 6 plus 8 square, this will be 36 plus 64 equals to 100. And when you square 10, it will be equals to 100. You can see the same thing apply. When you multiply 3 also, 4. This is what you have. 5. This is what you are. That is how to write down multiples of Pythagorean triple. You can do the same thing for any other Pythagorean triple, provided their square, the sum of the first 2 square, 2 numbers equals to the square of the third number. Now, assignment. You have to calculate the value of y and x. You can see this, we have 2 triangles joined together. 1, 2. You have to find y first from the first triangle. You then now use y, second triangle, to get your value of x. The same thing applies here. You start from this first triangle. This 1 triangle, 2, 3. Let me do one for you. Now, this is the longest side. Y square equals to 1 square plus 1 square. That is 1. 1 square, then that is 2. 1 square equals to 2. You can see the square root of 2 will not be a whole number. So you can leave it there and still use y square in the second triangle. The same thing with z. You now use z for the third triangle. That is that. Now, for further reading, you can get your new General Mathematics Book 2 on page 67 for more exercise and more knowledge on the topic. Till I come your way next time, have a wonderful day. Thank you for your time.